awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Okay, Assalamualaikum and hi everyone. So let's continue with the last part for set 5. Okay, so this is the last video for semester 1, sesi 2021-2022. So now let's look at question 22. So here we have an equation of standing wave. So given that y is equal to, okay, ini soalan standing wave from chapter 10 7 cos pi x sin 2/3 pi t. Okay, so based on this equation, okay, look at here, okay, that this is the general equation. Untuk standing wave, general equation dia apa? A cos kx sin omega t. Okay, so daripada sini you boleh nampak lah. A is equal to 7 for standing wave. K is equal to pi. And omega is equal to 2/3 pi. Okay, so which of the following represents a displacement against time graph at x equal to 0? So kalau kita gantikan at x is equal to 0, equation y kita akan jadi apa? At x is equal to 0, so equation kita akan jadi 7. Kalau x0, cos 0 is equal to 1. 7 sin omega t. Kan? Omega tu kita gantikan lah. Nilai dia. Tadi apa? 2 pi over 3t. So daripada sini you nampak graf kita adalah graf sin. So jawapan C dengan C dengan D dah salah dah. Kan? C dengan D dah salah. Okay? And then kita perhatikan pula A dengan B, apa bezanya? Dia punya amplitude 7 and 3.5. Okay, so this is the graph of equation untuk standing wave. Jadi kita mesti pilih inilah dia punya amplitude of the equation tadi. A dia adalah 7. So the answer is A, bukan B. Boleh? Okay, next question 23 and 24 are based on the following statement. Okay, so a tube of 60 meter long is closed at one end. Okay, resonance of second overtone occurs and the vibrating air column in the tube produces sound of frequency 992 Hz. Calculate the wavelength of the standing wave in the tube. So this is about closed part. Okay, so kalau saya suka lukis. Okay, so this is the closed pipe, and given that the length of the pipe is 60 centimeter, which is equal to 0.6 meter. Boleh And the frequency produced, dia sebut dekat sini apa? Second overtone. Baca betul-betul. So second overtone untuk closed pipe is actually equal to berapa? Second overtone is actually equal to fifth harmonics. Okay. Fifth harmonics. So soalan minta kita kira wavelength, lambda. So kita ada length, kita ada wavelength. So bila fifth harmonics, kita kena lukis dulu. Untuk kita selesaikan, kena pandai lukis. Okay. So fifth harmonics, so fundamental mode untuk closed pipe, saya bagi tahu awak apa shape dia. Shape dia adalah bentuk C. Kan? C terbalik ni. Okay. Jadi for fifth harmonics, second overtone is equal to fifth harmonics. Okay. Means that kena lukis bentuk ataupun pattern C tu 5 kali. 1, okay, 2, 3, 4, 5. Okay, so pastikan hujung ni adalah antinode. Okay, so kalau kita cuba bahagikan, kita ada 1, 2, 3, 4 dan 5. Okay, di mana 1, okay, ini adalah lambda over 4. This is another lambda over 4. Okay, lambda over 4 yang ketiga. Lambda over 4 yang keempat. And this is lambda over 4 yang kelima. So, kita nak kira lambda. So, kita tahulah ini ada berapa? 5. L is equal to 5 kali lambda over 4. Kita ada 5 lambda over 4. 1, 2, 3, 4, 5. Okay. So, L soalan dah bagi. Therefore, okay, lambda is equal to 4L over 5. So, bolehlah kira. L is 0.6 over 5 and the answer is equal to 0.48 meter. Okay, so ini dia. And then question number 4, we want to calculate the fundamental frequency. Jadi untuk closed pipe, equation dia apa? Fn is equal to NV over 4L. Boleh? NV over 4L. Jadi, V dia tak bagi. Okay, kalau you nak guna formula ni tak boleh. Kenapa? Sebab dia tak mention pun nilai V ni berapa. So, kita tak boleh kira guna formula ini. Tapi, dalam soalan dia dah bagi. Bagi apa? Frequency. Frequency of second overtone, di mana second overtone is equal to fifth harmonics. F5 is equal to 992 Hz. Ini maklumat yang you kena tahu. Second overtone is equal to fifth harmonics. So means that the frequency given, okay, produce sound of frequency 992 Hz, which is at fifth harmonics. Okay. So daripada maklumat ini, awak mesti tahu relationship. Relationship. Ingat tak formula ini? Fn is equal to NF1. Okay. Where F1 is the fundamental frequency. So, soalan minta fundamental frequency. So, kita nak kira ini. Okay, F1. So, kita boleh gunakan maklumat F5. So, since F5 is equal to 5 kali F1. Therefore, F1 is equal to frequency of fifth harmonics over 5. So, dia akan dapat 992 bahagi dengan 5 lah. Okay. So, you akan dapat 198.4. So, fundamental frequency is equal to 198.4 Hz. Okay. So, the answer is A. Okay. And then question 25, Doppler effects. Okay. So here we have an eagle flies directly towards a stationary man. So the observer here is stationary. So ini awak, okay. V observer is equal to 0 since stationary man. Okay. If the eagle move at 15 meter per second and screeches at 3,200 Hz frequency while flying, so what frequency does the man receive if the speed of sound is 340 meter per second? Okay, so jadi burung tu bergerak menghampiri ataupun approaching. Okay, this bird, saya memang tak pandai lukis burung. Okay, macam ni lah. So, the bird is approaching the man. So, the speed of the source, okay, the bird is 15 meter per second. Okay, so masa dia bergerak, dia mengeluarkan bunyi. Bunyi dia mestilah didengar oleh siapa? Mesti didengar oleh lelaki ini. Okay, so given that the speed of sound in air is 340 meter per second. Okay, and the source, the frequency of the sound is 3,200 Hz. So now, look at the direction of V and Vs. So V is to the right, Vs also to the right. Same direction. Okay, saya dah bagi tahu dalam video sebelum ni. Okay, same direction. Okay, nanti dalam equation dia adalah negatif. Apa dia negatif? Okay, apa yang negatif ni? So, equation for apparent frequency ataupun frekuensi yang akan didengar oleh lelaki tersebut is equal to V. Kan equation dia adalah V plus minus V0. So, yang atas ni kosong lah. Sebab stationary observer. Okay. Over V plus minus Vs. So now since the direction of V, awak tengok dekat sini, direction of V here and Vs is the same direction which is to the right. So kita consider the negative. Itu cara mudah untuk you ingat. Okay. And then times the frequency of the sound. Okay. Ataupun frequency of the source. Okay. And kita kira sajalah. Okay. So this one is 15 and times 3200. Okay. So jawapan dia you akan dapat 3348 Hz. Okay. So kalau you perhatikan dekat sini, jawapan yang kita dapat ini lebih besar daripada 3200 Hz. Okay. So ingat balik konsep dia. Okay. When the source kan bunyi itu datang dekat awak, so you akan dengar bigger frequency than 3200 Hz. So betul lah kita kira kita dapat lagi besar daripada 3200 Hz. Boleh? So the answer is C. Okay? And then next question, question 26. Okay? We have 20 kg mass is hung from 20 meter long vertical wire. So here we have a wire. Okay? This is the wire. And then kita letak apa? Kita letak pemberat, mass. So means that we put a force which is the weight of the block. Okay? If the wire is elongated by 3 millimeter, means that the elongation is 3 millimeter. Okay? Calculate the strain energy stored in the wire. So we want to calculate the strain energy. Okay? U is equal to half Fe. So this is the equation of strain energy. Okay? So F ini apa dia? Ini adalah force yang kita letakkan pada tali tersebut. Okay? Means that in this case, the amount of force that we put, okay, on the string adalah mass tadilah, adalah weight of the mass. Okay? So kita akan masukkan U is equal to half. F kita adalah force yang kita letak pada tali tadi, pada wire tadi adalah the mass, the weight of the mass. Okay? mg. Okay? Times E. So, M, 20 kg. So, 9.81. So, the elongation, soalan bagi 3, exponent negative 3. So, you akan dapat 0.2943 joule. Okay. So, the answer is B. Okay, very simple. Alright. So, next, question 27 from chapter 12. So the coefficient of volume expansion of copper is given, okay, which is gamma. It's given 5 times 10 power of negative 5 degrees Celsius per degree Celsius. So find the temperature change. So we want to find delta T, okay. So that a copper cylinder experience 0.2% increase in volume. Okay. So 0.2% increase in volume. Maksud dia apa tu? Maksud dia adalah 0.2% daripada initial volume. Okay. Maknanya dia suruh kita kira berapa temperature change delta T bila mana the copper cylinder mengalami peningkatan volume sebanyak 0.2% daripada its initial volume. Okay. Boleh di mana dia punya delta di mana dia punya delta V. So ini dia punya delta V is equal to 2 times 10 power of negative 2 V0. So sekarang by using equation delta V is equal to gamma V0 delta T. Therefore, we can find delta T is equal to delta V over gamma V0. So, substitute delta V is 2 times 10 power of negative 2 V0 over, okay, 5 times 10 power of negative 5 V0. Okay, so this one you can cancel out. Therefore, delta T you akan dapat 40 Kelvin. Okay? So, the answer is B. Kenapa? Boleh lah. The answer is B. Okay? So, very simple. Cumanya kena faham lah bila soalan kata so that a copper cylinder experiences 0.2% increase in volume. 0.2% increase in volume means that delta V. Delta V dia adalah meningkat sebanyak 0.2% from its initial volume V0. Okay? Alright. So question 28. So here we have an ideal gas is kept in a container with a volume of 2 liters. Okay, volume ni pastikan you tukar kepada, okay, so V is equal to, you tukar kepada meter cube. Okay, jangan lupa lah. Paling penting sekali. So, at a temperature of 27 degrees Celsius, so when T is equal to 27 degrees Celsius, saya tukarkan terus kepada Kelvin. Okay. And then, given that the pressure of the gas, okay, calculate the number of moles of the gas. Okay, ni simple sangat lah. Kita nak kira N. So, kita hanya guna formula PV is equal to nRT. Okay. And then, kita boleh cari N lah. N is equal to PV over RT. So, you substitute all the values, you akan dapat 0.12 mole. Okay. So, the answer is A. Next, 29. Given that this is N is equal to 2 moles of oxygen gas at the temperature, so we want to calculate the internal energy. So, T soalan dah bagi 30 degrees Celsius, make sure you change to Kelvin. Okay, so this one is 303.15. So, you nak cari you nak cari the internal energy, right? U. So, formula dia apa dia? Okay, sekarang dia punya apa nama ni? Dia punya perangkap dia ini oksigen. Okay, so this is diatomic. Okay, diatomic gas. Okay, so dia punya degree of freedom F must be equal to 5. So formula untuk internal energy F over 2 nRT. Ini. So trik dia dekat sini saja F ni. So F tu you kena tengok lah. So oxygen, so 5 over 2. And dia dah bagi R 8.31. T must be in Kelvin. Sama juga. T kalau dalam degree Celsius, you akan dapat salah. Okay. So the answer is 12.6. Okay. Exponent 3 joule ataupun 12.6 kilojoule. Okay. So the answer is C. Okay. Ni ramai salah ramai salah juga ni sebab the degree of freedom dia tak masuk 5. Mungkin dia letak 3. Okay, ingat 3 for monoatomic. Okay. And this is the last question. Question number 30. Okay. So here we have 0.2 mole of air in a car tire has a volume. So given that the number of mole 0.2 and the volume is given in meter, check dia punya unit. 5 times 10 power of negative 2 meter cube at a constant temperature T. Okay, which is T is 17 degrees Celsius. Okay, you boleh tukar teruslah kepada Kelvin. So it is equal to 290.15 Kelvin. Okay, it is then compressed to a volume. Okay, means that this is initial volume. So final volume dia compress sehingga 3 times 10 power of negative 2 meter cube. So now we want to calculate the work done. Okay, so sekarang soalan kata apa ni? Constant temperature. Okay, so always remember for isothermal process. Okay, apa formula untuk you kira work? Okay, ada dua. Okay, yang pertama, nRT ln V final over V initial. Okay. Tapi kalau you ada pressure, you boleh kira work is equal to nRT ln P initial over P final. Okay, jangan tertukar ya. Initial dengan final, siapa duduk dekat atas dengan siapa duduk dekat bawah. So, kalau volume, final over initial. Tapi kalau, pressure, initial over volume. Okay. So, sekarang kita dah ada volume. So, kita akan pakai equation ini. Therefore, work is equal to N. Soalan dah bagi. R 8.31. Temperature must be in Kelvin. And ln. Okay, V final 3 times 10 power of negative 2. Okay. Over 5 times 10 power of negative 2. Okay, yang belakang ni you boleh cancel negative 2 ni. Tekan kalkulator elok-elok, awak akan dapat negative 246.34 joule. Okay, so the answer is A. Boleh? Alright, so finish all questions for set A, which is DAQ questions. Okay, so I hope you guys can understand all the questions and all the best for your final exam. Okay, jawab elok-elok, tekan kalkulator elok-elok, keluarkan semua maklumat dan jangan panik. Okay, so good luck dan jumpa lagi dalam semester yang kedua, insya-Allah. Jika saya ada masa dan kelapangan, kita akan jumpa lagi dalam next video. Okay, Assalamualaikum dan selamat sejahtera. Bye bye and good luck.